So there are several classifications of discontinuity. We're going to talk about them next. We can just call them types of discontinuity when we talk about classifying discontinuities. So the two main divisions are removable and non-removable. So basically removable means that the limit exists and is a finite number. I could have just said the limit is a real number, but I only thought about the finite part after the fact. So these are two functions where f of x is not continuous at c. So in all these cases, we're talking about when f is not continuous, it's called a discontinuity. All right. In this case, the limit as x approaches c is whatever this y value is, but it's clearly a real number. It's a finite real number. Same with this one. So f of x is discontinuous. The function value exists, the limit exists, but the function value is not equal to the limit. That's why the function is not continuous at x equals c. And the type is removable because the limit, in fact, does exist. The limit as x approaches c from the left and right are the same. They are whatever this value is. So as long as the limit exists, we call that a removable discontinuity. All right. Then the other type is called non-removable, and that's what happens when the limit as x approaches c of f of x does not exist or is infinite. All right. So these fall into two different categories. One's called a jump discontinuity, one's called infinite discontinuity. So the jump discontinuity, like a mathematical way to say it, is that the limit from the right and the limit from the left are both real numbers. That is, neither one of them is infinite. And basically it looks like this. This is what a jump discontinuity looks like. We've seen a lot of them now. All right, that's called a jump discontinuity. And then an infinite discontinuity is, like in this case, the limit in fact does exist. The limit as x approaches c of f of x does exist in this case. It just happens to be infinity. So or is infinite. All right, happens to be infinity. And so this is called an infinite discontinuity. In this case, the limit does not exist. Limit from the left is positive infinity. Limit from the right is negative infinity. Here's a case where the limit from the left exists and is finite, but the limit from the right is negative infinity. So you could have that happen too. In any of these cases, we call it an infinite discontinuity. Infinite and jump discontinuities are both considered non-removable, whereas with the limit exists, we call that a removable discontinuity. So basically, like, this classification is important between these two because in the case of the removable discontinuity, why we call that is you could make the function continuous just by changing one point. All you would have to do is define f of x to be whatever this y coordinate is, and then this function would be continuous, 1 point. You could change 1 point to make this function continuous. Just move this weird point up here, just move it down into the hole, change 1 point, and now the function is continuous. So you can remove that discontinuity by changing only 1 point on the graph. All right. However, in the non-removable discontinuity, like in this case, in order to make this function continuous, in order to make the limit exist, I would have to drag a whole mess of points, you know, in some little neighborhood. I'd have to like drag them down here. So no matter how small I make that interval, there's infinitely many points in there. In order to make this function continuous, I would have to change infinitely many points. The same is true if you think about it of the infinite discontinuities. So the difference is removable discontinuity, I can change the function and make it continuous by changing only 1 point. In the non-removable discontinuities, in order to remove that discontinuity, I would have to change infinitely many points. So it's sort of an infinitely harder job to do. And then importantly, by the way, all of the instantaneous rates of change we've done have graphs that look like this, all of them. They are all removable discontinuities, and that's essentially why we can define a single value and have that instantaneous rate exist. All right. Whereas if the rate of change when I graphed it looked like this non-removable one, then I would not be able to talk about an instantaneous rate of change of the function. In fact, that would be called non-differentiable. We're going to talk about that later. Okay. Once we get the idea that some types of discontinuity are removable, then we'd like to remove them. But first, let's classify all of these discontinuities. So here's a function f. This function is discontinuous at 5 points. I just called them C1, C2, C3, C4, C5. I would like you to classify these discontinuities and state where f is continuous, because this is going to be fairly similar to the homework that you're going to do on page 84. So I will pause this video and come back with the answers to this in the next video. So you see if you can classify all these discontinuities based on what I just said, and come back and see if you get the same answer as me.